Welcome back. Let's talk about the Cambrian period, shall we? So the Cambrian period began around 541 million years ago, was the first period of the Paleozoic era. Just a reminder, if my computer would work. Aha. So kind of by the late Cambrian, the end of the Cambrian, North America was kind of right around here as a reference. And this is kind of what the world looked like. A lot of oceans. In North America, hovering just south of the equator. This line here is the equator, so just south of the equator, we see North America, again tilted like this. You can see Arizona is located right here. That becomes very important, especially up in this area of Canada here shortly. So what do we see? This is the symbol for the Cambrian. Looks like a C with like a little line in it. What do we see in the Cambrian? So the black line indicates carbon dioxide, CO2 in the atmosphere. A lot of carbon dioxide in the atmosphere. That's from volcanic eruptions that have occurred in the past. That's from organisms that are now emitting carbon dioxide, but again, mostly into the oceans. Remember, there's no plants, there's no trees, there's no nothing to start off the Cambrian, so there's nothing to kind of suck in that carbon dioxide, so we see, high amounts of carbon dioxide on the rise. The blue here is glaciation, so at 90 degrees, so the North and South Pole, 60 degrees, 30 degrees to the equator. So we don't have any major glaciation here. Atmospheric oxygen is the orange line. We have a little bit of it as well, and on the rise, at least initially in the Cambrian. So we start up the Cambrian with the Cambrian explosion. It wasn't a literal explosion. It was a figurative explosion, and where we see a rapid diversification of life, all in the oceans. Again, life was only common in the water at this time. Land, there was nothing. It was barren, subject to erosion. That material would be weathered and eroded into streams, then eventually into the ocean. Nothing on land for the most part. But again, we get this burst of evolution from around 545 million years ago, so actually a little bit before the beginning of the Precambrian as we have it, to about 525 million years ago. And again, it wasn't a literal explosion, it was a figurative explosion. We get a rapid diversification and proliferation of diverse life in the oceans. Most of these creatures that evolved during the Precambrian are extinct, and we only know them from their fossils. But as we get into coming out of the Precambrian and into the early Cambrian, evidence in the fossil record shows that all major phyla, divisions of life, were actually already established coming into the Cambrian. We have fossil records of early ancestors of all these different divisions of life. Boop, 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 boop. Including chordates. That's where we're at. Things with a spine, a backbone. That's where this is. Okay, so again, the Cambrian period, about 541 million years ago to 485.4 MYA million years ago. Two things make the Cambrian period notable. Again, the explosion of life, of all major groups evolving in a relatively short time. So that's why kind of, oh my gosh, all of this life is here all of a sudden in 40 million years. That's a short amount of time. Second was the rise of kind of a new type of animal that have hard shells, and things that have hard material to it are have a much better chance of being fossilized. Things that are very soft, like think of jellyfish or these other things like that existed early in the Cambrian are very soft body, and they don't preserve very well. They do, but in some places, but they're very hard to preserve and fossilize. Originally, scientists and geologists defined the Cambrian as the point where fossils kind of first appeared, but that's kind of been revised because prior to 541 million years ago, we have found fossils now earlier than that. So now the start of the Cambrian time is kind of determined mostly by when hard-shelled fossils first appear. We do get some bigger life, about a little bit back in the Ediacaran, before 541 million years ago, but so we just kind of kept the Cambrian period though the same time, even though we found fossils from earlier. So the type of life, we get a lot of primitive animals called sponges are evolved. Many kinds of invertebrates and the first vertebrates, fishes, appeared in the fossil record. And some cute little small invertebrates called trilobites become abundant. So let me show you kind of what the early oceans would have looked like. Some sponges here, again, some jellyfish. We start to get some fishes in here as well, some shelled organisms, including these little things called trilobites. And I'm sure a number of you have seen trilobites. They kind of look like this. They call it, so tri meaning three, lobe meaning three sections, 1, 2, 3. Trilobites. So 1, 2, 3. So they got three sections to them. 1, 2, 3. 1, 2, 3. Trilobites. Cute little things. Now, one of the most important rock units that kind of helped us to stumble on this Cambrian explosion is called the Burgess Shale, and that's found up in Canada. It contains some of the best records of Cambrian fossils, including the soft-bodied ones, which are really, really hard to fossilize. Usually the shelled stuff can fossilize pretty good, but the soft organisms are kind of hard. You need some special conditions. So we have shale, which is kind of a very small sedimentary, fine-grained sedimentary rock found in the shallows of the ocean. So remember from the unit back when we were talking about transgressions and regressions, we have sandstone, nearshore, kind of shales eventually formed from sediment deposited in the shallows of the ocean, and limestone a little bit deeper. So kind of in the very shallows of the ocean where silt is deposited, that would eventually make shale. This is the type of rock that we find this explosion of life up in Canada. It's up on the Canadian Rocky Mountains. Remember, Earth wasn't always, just because it looks that way now doesn't mean it was always that way. So people are like, well, how are there fossils on top of a mountain? There's a lot of conspiracy theories out there lately. Oh my gosh, like, see that, and then that must mean there was a flood and there was animal, organisms living at the top of the mountains. No, dum-dum, the mountains weren't there yet. All right, mountains eventually get raised up, and that was the case here. So just because there are mountains now up in the Canadian Rocky Mountains, doesn't mean it was always like that way. Initially, they were kind of below the oceans. In this case, shallows of the oceans. So we can find this Burgess Shale in British Columbia province in Canada at Yoho National Park, and we can find it right there again up in the Rocky Mountains. Again, high up in the mountains. But if we kind of go back to the Cambrian, we can see where this little star is. I mean, this is the location in which the Burgess Shale is located. You can see it's in this light blue, which is the shallows of the ocean. Again, coming to this paleogeographic map in this kind of lighter color, again, in the shallows of the ocean. All of that makes sense. So here's what we see. Here's a cool example of a trilobite, 1, 2, 3 lobes. Here's the shale, very much layered, fine-grained, layered sedimentary rock, way up in the mountains. And again, just because it's mountains now doesn't mean it started like that, right? We have the shallows of the ocean. Something later came and pushed all this stuff up. So this is a protected site. You can't just go up there and just take all the fossils. This is a protected site in a national park, so you can't take anything. You can visit there, but you can't just take anything from there. If you are interested in Cambrian fossils like trilobites, in fact, if you ever have the time to drive up just north of Las Vegas a little bit, there's the Oak Springs trilobite area where you can actually go and hunt for fossils, hunt for trilobites. They're not super spectacular like we find in the shale up in Canada, but they're still cool fossils nonetheless, and I believe it's totally free. I think I drove by here once, and it's totally free, and you can just dig around in this kind of, again, shale environment that tells us, obviously the shallows of the ocean were here at one point. And we're 9 times out of 10 when you're looking at sedimentary rocks, especially sandstone, shales, and limestones, 9 times out of 10 you're looking at the area was once covered by the shallows of the ocean. But anyway, that's kind of the Cambrian. Again, we're here in this area. As we continue our journey through the Paleozoic, we'll get into the Ordovician, where we start to talk about plants and other things. But again, here in the Cambrian, some very soft-bodied material like jellyfish. We start to get some cool things like trilobites with hard shells. Again, some other critters as well. And we start to get the first fish, the first organisms with a spine. But we'll go ahead and pause there, and then we'll continue this journey when we come back, and we'll jump into the Ordovician.